there we go. I'm now actually recording the session for those people who can't make it. As I said, something will probably go wrong here. I'm sure that some of you are having audio problems, some of you are having video problems, and in any minute, 1,000 screaming students are going to start invading Millbank and will get evacuated. But in the meantime, I thought it seemed to be a good opportunity to do a little bit of a tech talk about Upstart. In particular, I wanted to sort of talk about some of the history of Upstart and sort of why some of the design decisions were made the way they are, and sort of where we came from when we started doing this and what our ideas were. I'm going to try, obviously, use the whiteboard. It seems to be much easier to read if you actually press the full screen button. The little window you get by default is smaller than the actual stream. So if you're able to full screen it, you should be able to get more resolution. And I'll try and write as big as possible while I'm talking. Now, you can all follow along on IRC, the Freenode Ubuntu Tech Talk channel. And if you're on there and you ask some questions, Andy will try and let me know that someone's asking on IRC, and he'll relay it into the room. So we can see if this works. If this all works, I fully expect everybody else to start doing these as well, because if it doesn't work, then I fully expect everyone else to laugh. Right, okay, so as I said, I'm going to do this with the whiteboard. I'm going to be talking along. Please ask questions as you go, and I'm going to sort of try and cover some basics of Upstart and why it works the way it does. Okay, well, I need to get hang on, just a quick question. Is this side of the whiteboard easier to read, or is this side of the whiteboard easier to read? No, no particular preference. Okay, I'll write in the middle.
It's only just actually broadcast that.
No, clear it out while
Kitty says the right is easier to read.
He's right.
Okay, so first thing I wanted to cover is we always talk about Upstart being an event-based init daemon and not a dependency-based init daemon. So I wanted to just briefly cover what that means. It's one of the things that everybody kind of knows, but I've tried to explain it and I've tried to describe it, and generally done a pretty poor job over the years. So I'm going to do an equally poor job, but this time on video, so at least you can record it back and watch it again later and try and figure out what I really mean. Okay, so the idea of dependency-based init daemon, we'll cover that one first, is that we have a bunch of services. And I'm going to do these as thickly as I can because I realise we don't have much contrast. Right. Now,
That's nice and clear.
Excellent. Right. So the idea is we have a bunch of services. We have service A, service B, service C, service D, and service E. Okay? So each of these services are things we need on startup, and each of them depends on something else starting first. You could create a theoretical idea of a tool chain here, where that A might be the desktop services something, B might be a daemon required for desktop services, C C would be something like a the dbus, D&E would be your hardware. It doesn't really matter. The idea is that we have a set of services. Now, what happens here? The init daemon knows about these set of services. The dependencies of the set of services are defined in the init daemon's configuration, and when it starts up, it's able to determine what order to start these services in. And this comes very much from the original idea that we have a sys5 init. Everything started in one line. There's no easy way of parallelizing and stuff. If you know dependencies, you can parallelize and you can automatically sort and you can automatically do one thing or not. Okay, and that's actually really easy. Computational science 101, whatever. It's if you want to find out what order to start these services in a manner that allows dependencies, you iterate it as a tree. And I think it's you do post order, so you would write B, D, Yeah, E, C, A. Yeah. So you iterate your post order dependency, and you end up with a list of services that you need to start. So in front of that. Okay, so that's dependency based in it. The reason everybody kind of latched onto this is it works a bit like package manager, and we all know about how to do dependencies in the package manager and requirements. So we kind of latch onto this, and it works really nicely, and we understand how to do it. Now, the problem with a dependency-based init system, well, at least, and when I say problem, you have to bear in mind, I am only speaking about my point of view, and you know, as somebody who's thought about this far too much, and really sort of tried to work out what the hell's going on in his life, and so on. The problem with this is, you know, if you draw on the whiteboard like this, it looks like the dependency tree, that's all you have. But in fact, it's not quite that simple, and actually it's not a binary tree at all, and there's actually a service G there. Service G is depended on by a service H, which depends on service K, which actually also depends on service E, which depends on service M, and so on, and N. So the actual boot sequence is a graph, and in fact, I'm just going to stick another one over here. And that is service O. Yes, sorry. Sorry. Hello. Yes, I random letters to make it easy to read on the whiteboard. And we're still not on fire, that's good. Okay, so we have something a little bit more like a graph. It's a little bit more harder to do than post-order traversal. We have to start from any given of these points and do a directed graph traversal. But directed graph traversals are an understood problem, and you can all pick up clues and work out how to do that. So yeah, again, that's what it really looks like. But the real problem is I've run out of pens. The real problem with a dependency-based init daemon is actually knowing what you need to start in the first place. This O thing over here, this might be a service that you actually don't want running, or do you actually need to start? If O's not running, there's actually a service here called P. Now, if O's not running, you don't need P. Now, the reason this is kind of interesting is because otherwise, if you just defined all these services and they're all going to be running, then you may as well just define, save time on boot. You're spending all that boot time traversing the graph, figuring out the best order, when in fact the service is pretty much defined. They don't change much and so on. So it's all static. It's all static. You can just blitz it, write out a config and boot. And that's what a lot of the sys5 init style symlinks and stuff are. You save time on boot. You don't worry about calculating this every time it doesn't change. Now, when it does change, though, you actually need to know what services to run and what services not to run. Just for historical reasons, Solaris SMF actually just starts everything. It just assumes every service is to be started on boot and only uses the dependencies to figure out the order. That's just a bit of historic there. Now, so what you actually end up doing is you need to say, well, which services are your goal services? So A is one of our goals. We really, really want A to come up. I hope that shows up on the camera.
Not very well.
Not very well? All right, okay. Right, I'll fill it in then. Does that show up?
Yeah.
Right, so A is one of our gold services. Oh yeah, that really shows up. G is going to be one of our gold services. And K is going to be one of our gold services. Sorry. Yeah. H isn't, we don't care. Now, if we actually know that we need to start A, G, and K, then we now know, for example, that we do need to start B, because B is a dependency of A. We do need to start C. We need to start D, E.
Yeah, that's clear.
M, we need to start. But we don't need to start H, which is a bit of luck because it's hidden in the light up there and you actually can't see it. And we don't need to start O, even though it's a top level service, and we don't need to start P, even though it's a leaf. So we've actually wandered off the camera. So we've actually already eliminated a bunch of services. So we start those services and so on. And again, this makes sense. If you think about it this way, it makes sense because you know, if you're in a package manager, you don't install O, you're not going to get P as a dependency. If in a package manager you install 2 libraries, G and K, you don't get the package H, even though it depends on those 2 libraries. You know, this makes sense to us. This is an easy thing to understand. So I'll leave that on there a second while I drink tea. Okay, so here we go. Dependency graphs, dependency-based init systems. They work exactly like a package manager. Now, the interesting thing about dependency-based init systems, I'm just going to remove a bunch of the extra services we're not starting. So we're not starting H. K is a different graph. We're not starting O, and we're not starting P. So we have a small graph. Now, let's say we stop K. That's this one. If we stop K, the dependency-based init daemon has choice. M is still running, and E is still running, both the dependencies of K, and some dependency-based init daemons leave that as it is, and some would actually go and stop M because there are no dependencies. And that's really a choice of the dependency-based init daemon. Of course, the obvious problem with a dependency-based init daemon, if it does stop everything, is if you only end up with one goal service and you stop the goal service, your machine shuts down, which is probably not the desired effect, but is unfortunately the practical effect. Okay, so yeah, that's a difference. So initng doesn't stop services because of this reason. I actually don't know whether systemd does or doesn't. It is a dependency-based init daemon. I'll get to that in a bit. And I'm not entirely sure sort of what the others do. SNF does stop the services. SMS does, not initng doesn't, and don't know what systemd does. I'm sure someone does. Anyway. Okay, so there we go. Dependency-based init. That's sort of the challenges and problems with dependency-based init. Now, clean whiteboard.
The word on IRC is thick lines aren't necessary.
Okay, great.
Pity says systemd doesn't auto stop services as far as I know.
Okay, so now, so we had a look. So this is long time ago, and I can remember we were starting to have replace init BOFs at our Ubuntu Developer Summits as early as the Australian one, which was the first one. We had BOFs and sat around the tables with little silly signs and the schedule from hell on the whiteboard and whiteboard on the wall. So as far as I remember, people have always been pitching that we should replace the init daemon with an Ubuntu from the very first time that anybody could pitch. So we've obviously done looking this over and over again. And one of the first reasons we kept rejecting such a thing, I can't remember where I think Paris was possibly the next time we rejected this, was that the problem we kept, it can't be Paris. No, it can't be Paris, it was somewhere else. Anyway, it might be Montreal. I can remember the room, I can't remember the actual UDS location. Anyway, one of the rationales there was that we were still looking at this problem of, well, yes, we could take our existing init scripts, we could add LSB dependency headers to the top, we could run stuff over them, but what we've ended up with is just an automatically ordered list of symlinks again. Yes, there are init daemons. Wiesbaden? No, Wiesbaden was already Upstart was demoed. Anyway, I remember Tom May was working for us anyway. So we sort of thinking that was a good idea, and all of the init daemons that replaced init at the time did all this pre-calculation on boot every time, but again, it was no different from anything, from actually calculating it on static. So we kept looking at it and so on. And then launchd came to our attention, and it's launchd is one of those sort of interesting things, and it works very interestingly. Now, launchd is not a dependency-based init daemon, and in fact, it just isn't. Launchd is actually far more interesting. It's an inet SuperServer. And this is always worth talking about because quite a few people miss how launchd actually works. So you have the init daemon. I'm going to try and avoid the top of the whiteboard. So the init daemon goes and reads all of its services, and each of its services define ports to listen on, TCP ports, UDP ports, and I'll get something else in a minute. So the init daemon might be listening on port 80, port 22. Don't worry if you can't read the numbers, I'm just giving some examples. And I don't know, 443, I don't really care. It's 25, let's put SMTP in. Right. So the init daemon listens on ports on behalf of the services, and yeah, that looks like a plot, that's kind of what I was aiming for. Now, normally, the way iNet works is the iNet SuperServer listens on the port. When you get a connection on that port, it accepts that connection, so it gets a new socket connected to the child, and then starts a instance of the defined executable, passes it the accepted socket as its standard input and standard output. The child executable is expected to go and go away and use that socket and exit once it's completed that socket. The socket is closed. In the meantime, iNet SuperServer was still listening on that socket, will fork off new additional children for each and every instance. The interesting innovation in LaunchD is that, yes, it listens on these sockets for anything coming in. However, rather than forking off and passing an accepted socket, once the socket's actually got a connection on it, it obviously holds true for reading, it then starts the service. So connected to port 80, you get a service, connected to 25, you get a service. Right. And to that service, it passes the listening socket. So the service itself, Apache or whatever 25 is, so I can't remember what it is on OS 10, probably SendMail or something, gets a copy of the actual listening socket. The service is running, and the service itself calls accept on that socket and gets the child connections. The service is permitted to keep the listening socket around, keep calling accept on it as many times as it wants to get additional child connections. The service is allowed to fork off its own children, it's allowed to handle children connections however it likes. And because the service is running, the actual LaunchD daemon doesn't listen and doesn't worry about the connections. So you end up with, while the service is running, the service is expected to be actually calling accept. Once the service exits, LaunchD goes back to calling accept. Sorry, not calling accept, goes back to selecting the socket. Calling select, not accept. And this is kind of interesting. And this is, means services are started actually when there's a demand for it. And this is where it gets really interesting, because, let me just get rid of that a second. Right. So services. So you can obviously listen on TCP sockets. Right. TCP, nice and easy. Yeah, that's going to start as Apache. That's going to start as a SendMail server, and so on. So we won't actually have a mail server running until somebody actually connects to it. And UDP, yeah, I think that's kind of one and the same thing. While packets are being received, if the service isn't running, send it the packets. If the service, let me just a bit obvious. If the service is running, just don't start the service, send the packets. Okay. Now, more interestingly than that, obviously we can listen on Unix sockets. Yeah. Now, Unix sockets are really interesting because I can't write Unix large enough. But is this fine? Okay. Unix sockets are really interesting because, in fact, when we say dependency in the dependency graph, what we really mean is that well, okay, let's say Apache depends on Postgres, our web app depends on Apache or Postgres, or we do it either way. What we really mean is our web app is going to connect to Postgres, right? It's going to connect to Postgres, it's going to need the database server there. It connects to, so we connect to the, so I'm trying to think how to word this easily. So right, so when your web server connects to Postgres, it connects over a Unix domain socket. Postgres is listening on a socket. It's a Unix domain socket, not a TCP socket. It may have a path on the file system, or in the next case, it may be on an abstract namespace, or so on. But fundamentally, it's still listening on a socket, and that socket is one that the init daemon can listen to instead. The init daemon can listen to var run.s.psgdsql 1234, and can start up your Postgres, pass it the listening socket, Postgres calls accept, gets the child connection, services it. Postgres can make its own decisions about whether a service is up and running, or whether to stay running, or whether to go away when there's no child connections, whether to time out, and so on. Okay, so the Unix sockets are really, really interesting, and also LaunchD offers a couple more features which I'll get to in a second, because these are actually, I'm starting to try and build a list here. Now, the other interesting thing is, and I'm going to be unfortunately nasty to somebody here, and is that OS X has mark ports, and I'll deliberately mispronounce that so you know I'm not talking about the Mac, I'm talking about mark ports. Now, a mark port is a type of socket that comes from the mark kernel, and it's a socket which, when described, will sound familiar to Linux people. The socket has a given name. That name might be ComApp or Windows Server. When you connect to ComApp or Windows Server, you're connecting to the instance of the Windows Server. That may be bound to a user or not, depending on the actual details of the socket or a mark port. They're called ports internally. You can talk an object-oriented protocol to the Windows Server over that socket, which is the mark protocol. And that protocol allows you to do IPC. Now, that protocol is communicatable between many, many of the system daemons in OS X, and actually the mark kernel itself and the drivers and so on. Now, the really cool thing about this, obviously, you have named sockets. I can have ComApp or Windows Server. That can be multiple users or just one of them. That is a different application to ComApp or Media Server, which I think has actually got a different name. It's called Front Row, I think. Anyway, ComApp or Front Row. Actually, I'm streaming this on OS X, so I could actually walk over to my laptop and look, but I'd cut you all off. You have ComApp or Windows Server, and the other thing is you can have different implementations. Nothing stops a service one service that has ComApp or Media Player. Nothing stops another service beating it and registering ComApp or Media Player first and talking the same object protocol. And these object protocols in Mark are quite well documented, and they're the method for IPC. So it allows you to have different options, with well-known names and so on. The service this reminds you of on Linux is dbus. And where I mean is that, unfortunately, my opinion of dbus is that somebody booted OS X, figured out a little bit about how mark ports worked, and then missed the fundamental point. Now, the reason they say they missed the fundamental point is in Mach, the communication goes by the kernel. So if you are doing a peer-to-peer communication between two processes, it's a socket communication between two processes, much like a Unix socket is. It's equally efficient, except the object orientation and so on overhead. Now, the problem with dbus is it isn't. You don't connect to a service, you connect to the dbus daemon service. The dbus daemon service also has a connection from the other service you're trying to talk to, and the dbus daemon acts as a broker between the two. Thus, to IPC from one service to another, you're actually doing a three-way IPC between the dbus daemon. If many, many services are talking simultaneously, that's only one instance of the dbus daemon service actually communicating and brokering every single transaction on the bus in dbus. And the other reason this gets unfortunately wrong is that obviously Mark supports service activation. And it supports service activation in hopefully a really obviously simple way. LaunchD can listen on TCP ports, it can listen on Unix ports, so LaunchD can listen on Mark ports, which means in a LaunchD configuration file, and it is stressed that OS X and iOS have gone backwards and forwards as to whether they think this is a good idea or not. I think the current trend is good idea again, because iOS makes extensive use of this. Is that you have you define your LaunchD agent or your LaunchD daemon or whatever, and in that you say it listens on a Mark port, say ComApp or Windows Server or something like that. So therefore the LaunchD daemon listens on behalf of the launch server, and so it listens on the Windows Server or whatever, reserving the name, so you have a policy of which services can have which names because it's defined in the LaunchD configuration file. LaunchD reserves the sockets and the service isn't started. However, if something makes an object-oriented request to the Windows Server is started. Just a bad example. Windows Server is actually their equivalent of X. The front row. It's a better example. Or any number of the services, print service, the everything else. They're actually started only on demand when you connect to the marked port, and you connect to the marked port by name. This would be brilliant because it's service activation. You can say, oh, yeah, I need to talk to the X server. You create a service app. You create an object. You just send a message. You connect to com-apple X server. You send an object-oriented request to it or whatever, and the service is automatically started. X comes up. It receives your request, replies to it. Your standard Unix bind semantics apply. Standard Unix connect and blocking semantics apply. Standard Unix write and read semantics apply. Everything standard applies. Bind. You have policy, the same policy as to who owns a marked port is the same policy as who owns port 80. It's all really nice and simple. This is the bit dbus gets badly wrong. In dbus, it's the dbus daemon that reserves the names, and it reserves the names through a policy. When you make a connection, because you're brokering through the dbus daemon for every message, when you make a message to you've got, I can't think of Ubuntu Upstart off the top of my head, but the many dbus messages you have, that services you can send. You make the request. The dbus daemon sees the service hasn't started, and therefore the dbus daemon itself acts as kind of like a mini init daemon. Works out how to start the service, works out how to pass the dbus socket, has to deal with all the problems of what happens if the service doesn't start, what happens, what message does it send back, is there a policy to allow it, pass the message over, worry about whether the service is still running. So you're brokering through this third-party daemon yet again to do service activation. So actually, in the Linux world, we don't have mark, we have dbus to take care of. Now, that means if we want, that means launchd doesn't work. You can't actually do launchd in Linux because of dbus. And that was sort of the big fundamental sort of rock we hit with our foot while because we actually really seriously thought about just trying to port launchd to Linux. And because of the design of dbus, you can't do launchd. And the real problem and shame with this is that at the time it was considered betterly political to worry about changing init daemon than it was to worry about changing dbus, because there was very much a considered a negative thing if we went around starting to change core system services like dbus, because it would be very un-upstream of us, even if we talked to upstream first. Okay, so we have dbus in Linux. Okay, now unfortunately we don't have marked ports. We have dbus. Now, okay, I did see Pitty's question. I'll get to your question in a minute, Pitty, please. I need to get to the bottom of my list and I'll answer your question. Okay, now. And the question for Pitty, you can see it on IRC. Just 5 minutes, yeah. Systemd does care about dbus. Now, the other thing we want to be able to do activation on is the other things that launchd can do activation on. File system. So by file system, I mean launchd can do kind of cool things like this service is running while a file exists in a given directory. This service is also running while there's a connection on the socket. This service while there's a file system in the directory, and we want to be able to do cron, so we want to be able to do time. Actd is the other one, and we want to do batch. The usual kind of how do we start a service, and how do we keep the service running, and so on. When should the service be running, and so on. And the other thing we have a problem with, more than say OS X has a problem with, is hardware. And I did actually plan this badly. Hang on. Okay, I'll use the side whiteboard. Okay, so the other thing we have to worry about in Linux is hardware. Now, this is kind of separate for a second, and I'll just do it on this side of the whiteboard. The reason we have to worry about hardware is in OS X, they're relatively lucky. Their system doesn't change that much. They have different SKUs, but they're in very tight control of them. They don't have to worry too much about hardware coming along, and they don't have to worry about someone ripping out the graphics card one day, sticking another graphics card another day. They don't have to worry about whether a network's up or down. They don't have to worry about whether the network's up or down because they're doing listening on TCP. So if the network's down, you're not going to get the service started because you can't connect to it, and so on. Now, the other things you don't really have to worry about in the OS X world are things like has the user stuck /user on a different partition? Is that partition on the same disk in the same enclosure? You know, and all of those kind of things. And this is something I'll just come back to in a minute. So what you have really when you boot a system is you have kind of you bootstrap, and it's like steps, you know. And only the last step is actually the desktop. If you're a desktop distribution, you know, you have the core OS, so you might have the firmware at the top. You might have the kernel. Well, I'm going to put firmware and kernel together actually. You have services beneath the desktop, but you also have core OS between the firmware and the kernel.
Don't go any further left.
Don't go any further left. Yeah, I was trying not to. Yeah, there's nothing over here. Now, your desktop services depend on your services. Obviously, your firmware is responsible for getting up the actual system and the graphics and everything else. And on Mark, that's quite well integrated. Core OS. Now, Core OS is the complicated bit, which is things like mounting file systems. It's things like setting the host name. It's things like setting the loopback device up, and all of the kind of kernel services. So I'll get back to this in a second. But we need to be able to bring all of these things up, and we need to be able to bring all of these things up in different ways at the moment. Now, in the sys5 init world we came from, is that firmware and kernel is obviously handled inside the kernel and BIOS in Linux and in Ubuntu and in Debian. The desktop is handled by things like GNOME Session. The services is handled by the init daemon, and that's the run levels: RC2, RC3, RC4, RC5. The core OS is the actual there's a very interesting difference between Red Hat and Debian. In Red Hat, the core OS part is an RC sysinit script. It's an almost hard-coded script that knows about particular things and knows how to bring up a core OS, mount all the file systems, check the file systems, bring up swap, set the host name, all of the kind of really core little pieces. And it's pretty much as I said, it's a hard-coded shell script. In Debian, and thus in Ubuntu, that's always been just as flexible as the run level system. You've always been able to pull out and pull in things like the core OS. So whereas, if you're just doing services, you might look at there, at the init daemon here. But if you're in the Debian and Ubuntu system, we actually had to consider the core OS bring up the mounting of the disks, RAID, LVM, all of those kind of things, and even driver loading. So we've actually really started, in Debian we've actually really started, in Ubuntu, we really had to think about driver loading as well, as part of this system. And honestly, once you're doing 3/4 of the bring up, you've already, in your head, decided you're going to do the desktop as well. There are 4 parts. Now, for example, if you're replacing an init daemon on a different OS, you might actually use, only consider the services layer. We actually considered all 4. And that was true of all the time we were doing launchd. Okay, so, bring up an OS. So many things we have to do. Your TCP sockets, unit sockets, dbus, file system, cron, active, whatever. Can I go more this way? Yeah. Right. We want, obviously, therefore, in Linux, we're also considering UDEV because we're doing the firmware with kernel. UDEV had just replaced hotplug at the time we were doing this, so it was a very cool, shiny thing that we were very excited about. And so UDEV, I mean, network events, file system events, and so on became very important to us. And obviously, the state of other services is very important as well, but I'll get to that. You obviously want dependencies in there, and so on. So once we kind of wrote all this down and figured out all of this, a design kind of presents itself that you'll consider going to do. Now, I'm going to get to your question in a second, Vinny, as I do this. So I need to sort of stand. Okay. I think there's a couple of bits missing, but I'll remember them as we go, and I'll remember to fill them in as we go. So the design that's going to present itself is going to be, okay, and this is pretty much where we went to next, which was starting to look at initng and booting and building stuff onto the side of initng. Now, each of these things is going to be a trigger that we're going to want to boot. Now, for us, our first priority, we sort of started from the bottom and went up. So our first priority is making sure we could do driver loading and stuff. We had UDEV, it just replaced hotplug, so we were going to kind of go with that. But building in support for making sure we got events from UDEV was, I used the wrong word there. Actually, events from UDEV was quite important first off. And the core OS was the next part we really wanted to consider, which was to be able to bring up the system to core OS level, so actually you could actually start any services. And finally, obviously, services is there as well. Now, so starting off with this, your obvious design is going to be you have a service-based init daemon. Now, service-based init daemon, I just mean a init daemon that actually knows what it's supervising, and you actually define the binary to be run rather than a shell script to start that binary or stop that binary. And that was very much the way everything went at the time, and I think still does. So that was kind of an obvious thing. The obvious thing then is it would be a dependency-based init daemon, because that's what everything exists at the time. And you would therefore have a large number of things that could, dependencies. So if you went to start service A, it would start all of its dependencies and so on. You'd then think about, right, okay, well, service is going to have dependencies. We can bring up the system, and dependencies kind of suffice for this services layer, but not the rest of the kernel in the core OS. For the core OS layer, we want to be able to start things when we get UDEV events. And so therefore, right, well, let's have a trigger system. Let's have a dependency-based init daemon which has a set of defined triggers that can start a service. So those triggers are going to be the things like UDEV events. Right, okay. So we have now a dependency-based init daemon running, doing dependencies, and also receiving additional triggers while it's running. In effect, things running the start command on its behalf when you get a UDEV event. And that kind of seems okay. Yeah, that's working. We can therefore, when we get a file system, we can start UDEV. When we get a file system, we can start LVM, we can start RAID. Another thing to bear in mind here is in Ubuntu, we've always constructed file systems forwards. This was something we started very early on, and we've kind of kept to it. Whereas we use metadata from LVM and RAID and so on to actually decide what to bring up. And we'll bring up all RAID arrays that connect to the system. We'll bring up all LVM devices that connect to the system. We activate every RAID array. We activate every LV. We just activate it to see what's in it. To activate the next bit to see what's in it. To activate the next bit to see what's in it. So when we get a block device SDA, if it's got RAID metadata, we will run MDADM. When we get a block device SDB, if it's got RAID metadata, we'll run MDADM. In theory, MDADM will activate that array. It will get MD0, we'll look inside it, we'll see LVM metadata, so we'll activate the LVM PB, we'll now get LVs out of that, so therefore we look inside those, we've got ext4 file systems with given UUIDs and labels, and if those are in FS tab, we mount them. That's pretty much the way we do. We forward bring up systems. We don't have big config files defining everything like the LVMs and RAIDs and everything set up. We just bring everything up that we can find. And I know that's different from other operating systems and other Linux distributions. That's just the way we've always done it. And we kind of started off down that path, and we made that path work, and so we've kind of stuck with it. Bring up mounting file system, start UDEV. Every time we're starting something, we're resolving a dependency tree. But okay, so we're resolving a core dependency tree in the system to bring up the actual services, but at the same time, we're receiving additional events and resolving additional dependency trees, which may or may not share graph nodes with the dependency tree we're already resolving. So we now got a dependency solver that's having to be flexible enough to actually deal with changes in the graph while it's solving the graph. Okay, bit more complicated, bit more interesting. The next thing we put in is dbus. This is where we get to Piggy's question. We put dbus into this system, and we will obviously activate services on dbus connection. Now, you can probably get away with not you could say, well, we'll just leave dbus separate. But once you've already decided you're writing an init daemon, you go the whole hog. You make sure it can replace everything. There's one place to define a service, and there are actual benefits to come when you come back to it later to actually have one place to define a service with many triggers. So UDEV is a new trigger. The system startup is a new trigger. dbus is now a new trigger. In other words, we're having the dbus daemon, which is a service itself, know about services that it can start, and it's effectively running a start command. So if dbus is told if a service that's been started by the init daemon, or as a result of the init daemon as a result of a UDEV event, is is then makes a dbus method call. We then need to start the dbus service on behalf of dbus, let dbus know it's started and listening and connected, and then let that do. But to start that service, we may also need to resolve dependencies. So we have this great big waterfall where we're continuously re-evaluating our dependency graph. And then from the start, and you have the TCP socket activation, Unix socket activation, which is very important for the services layer, which is still the layer we've never really tackled with Upstart, and the file system layer and cronapd. We have this great big waterfall of events and triggers happening. Great big trigger, all this waterfall happening, coming into the system, continuously resolving, the dependency solver. And the problem we found very early on, and with the core OS part, is that actually we ended up with being able to get to points where the resolution we had taken so far for the dependency solver was invalid for the new event that just came in, and thus we couldn't continue booting. And that was pretty much a bit of a bugger.
Question from the floor. Does Upstart have dbus integration?
No, not public. So it's not been used. We've not got that far. We've been doing firmware and kind of core OS, as I said. Starting at the top, working way down. So we've been doing each of these things individually, blah blah blah, and so on. So that was kind of the problem we had. We ended up with, we can't use a dependency-based init daemon because every time we hit trigger, the trigger could be too late. The trigger could happen in a state where we actually can't solve the dependency graph. The triggers could also very, very easily, and we did this with initng, get to the point where you could deliberately cause two things to happen, but the two things would deadlock. Because the one thing was waiting on the other thing, which was waiting on that, and you could very quickly deadlock the system. And so on. Hacking the core OS, it's much more interesting. So, that's where we get to. We have a whole bunch of things we want to trigger, and we want to have those. Blah blah blah. Okay, so we then went back. Right. Okay, we have a system initng. Initng cannot resolve this dependency graph, and we've got a system. We've already used init daemon. It was out there. We've managed to very quickly. I think it took us about 3 days. There's a guy, Jeff Bailey and myself, who went off and made that break, and we couldn't get it. So we went back and looked at the real problem again. And what we really had the problem was because, we were kept on evaluating the dependency solver every time through. The dependency solver graph was changing all the time because the set of services we wanted starting was changing. The original goal set, we had to keep adding to the goal set every time a UD event happened. We had to add to the goal set whenever the dbus event happened, and so on. And we just ended up with a headache. What we actually really, really wanted was an init daemon where each of these things was first-class objects in their own right, and each of these things, first-class objects in their own right, could pass through the init daemon in the same way. And so basically, we wanted to be able to say, right, okay, we've got a UDEV event. This UDEV event is happening. This happened at this specific point in time. This point in time is before all the things that happen later and after all the things that have happened so far. So when we get that UDEV event, we evaluate what that UDEV event can do now, and so we bring up the event, pass it through the system, might cause some changes. Now, if the event itself goes through the system in that way, can we then say put a dbus event, activation event through the system in the same way? Can we, if we've got a U event saying, right, this thing needs to be started, cause a dbus event to say this thing needs to be started? Well, obviously it's a trigger. So can we say, for example, a TCP event, can that say the same thing? Can we have the same first-class object we're using for dbus and UDEV, have a TCP socket that attached to it to say, right, this thing needs to be started and here's a TCP socket attached? Sure. Yeah, that seems to work. Same with the Unix socket. You can have the thing to say, well, this thing's in the file system. We have this time has happened. Okay, so we have all of these things we can collect into a first-class service. Sorry, first-class object, that actually contains an event of some description that's happened. Okay, so we have events. Those events passing through the system, they cause state changes in services. So services started by events, that's nice and simple. The problem is we're at this fundamental problem where services are therefore different, they have a dependency graph. So when we start a service, we need to solve a dependency graph to get that service started. That dependency graph things like that dependency graph really might depend on other things. Whole mess happens again. And the brainwave we had was that the service dependency graph could also be the same first-class object. So when a service is actually, you get a dbus event or whatever, it starts the service itself can say, right, well, I'm starting, and put that in an event, So ROPS, as well as a TCP connection, a Unix connection, a service starting is an event in its own right, and as is a service started is an event in its own right. Now, what would you do if a service is starting? Well, if a service is starting, you obviously need to start its dependencies. That's an event, but that's an event that passes through the system. So Apache is going to be started. Apache is starting is the right way we word it. Passes through the system the same way that a UDO event happened. Okay, so Apache starting goes through the system. The same thing that you use to listen on a U event can listen on Apache starting, and then that can cause that thing to be started. So you can do dependencies with the same first-class object. Interesting. I get to point. The problem there is how do you do wait and synchronization? So we'll come back to that in a second. Likewise, Apache has started the opposite, the end of the Apache starting cycle. The Apache is actually now running. Well, that's an event in its own right. That goes back through the system. So if we now know when Apache is starting and Apache is started as two separate events in the system, we can start things when Apache is starting because Apache depends on them. We can start things when Apache has been started because they depend on Apache. And as I said, we do everything forwards in Ubuntu. We just carry on from the very beginning and don't have hard code. So that was very, very attractive. We have removed the dependency solver. The dependency solver has gone away because the events, the act of starting and stopping and a service being started and a service being running is actually the same first-class object passing through the system as UDEV and dbus and so on and so forth. Then the other brainwave was that we could then, while the events have just an edge, they pass through the system, the thing that caused the event might want to know what's the event changed, and the thing might want to wait for the event change. So if the dependency of Apache takes a long time to start, you want Apache to wait for it. And that was the obvious thing then. Right, okay. So we put an event in the system, we say foo's happened, something's happened. That foo is going to go start a whole bunch of services or start a whole bunch of jobs or tasks. Okay. So we don't get the init foo command or dbus call or internal call doesn't yet exit. It's blocked because the foo event has been taken by things that have gone off and done some work. Each of those jobs and services has its own little state machine, obviously, to get itself started and work out when it's running. So they don't give that event back and say, right, I'm done with it, until they're actually running. So if a process takes a long time to exec, or it takes a long time to fork exec, and so on, you don't get the event back yet. So when that process is exec, it's started, you get the event back, and you get the started event and the event back as well, back to the original caller. So if you do emit foo and it starts a service, emit foo doesn't return until the service is actually running. Now, because emit foo doesn't return the service actually running, if a service's starting event is emitted, the service itself doesn't get its own thing returned until the actual services that are started by result of it starting have been running. So now you can do dependencies. So you could build a dependency-based init system using this simple technique. Everything runs forwards. There is no dependency solver. The dependency solver is just natural. It's, well, I've just done this, what else can I do? I've just done this, what else can I do? I've just done this, what else can I do? The I've just done this, what else can I do might mean I've just done this might be I've just been told to start a service, what else can I do? Well, I need to start obviously the next thing I've got to do is start its dependency. So you can build a dependency-based init system in this system. Likewise, you can decide whether a service is automatically stopped or not in this system by just adding two more events. So you can do stopping and stopped. You've now got both sides of a particular service's state and state transition. You can start services as a result of being started, and you can start services as a result of being started and of it being stopped. So you could have something run the end of the service, and events also can stop services. So you can now have services decide whether they automatically stop or whether they continue stopping. So this is something a little bit unusual. They didn't exist at the time, and because everything is one of these event classes, we call it event-based init daemon. And the most interesting about it, there is no dependency solver in it. You can still do socket activation, you can do unit activation, you can do dbus activation now, because the dbus command to start dbus, internally, it's passed to Upstart, then it would start, and start everything off. But there's no dependency solver, you're not changing the graph, you're just emitting events which will cause services to be started. Because events can be blocked, yes, you can end up in a situation where two services flip-flop between each other, or two services, one service fails to start because its dependency, its event was never fulfilled, but the system itself will boot. You can't stop the system from booting or infinite looping and so on. So this was the design we came up with, and this is the design we've been working on for the last few years, and it's taken lots and lots of individual refinement. It still doesn't do half the stuff on this whiteboard because, frankly, there was no there was no existing code. Not only was there no existing code, but there was no existing model for this. We couldn't go out and look at how another event-based init daemon behaved. There isn't one. It's the only one that behaves this way. A large part of it's been finding out whether this works. I can theorize that we can actually remove a dependency solver from an init daemon entirely by by using a very, very simple first-class object. I can theorize that. I can prove it on paper in theory that it works. But actually, when you go and you're dealing with an OS with God knows how many million users every day, you've got to prove it actually works. So it's had a long period of actually proving it worked. It's got obviously problems with it. There are syntax issues because the current implementation is very much geared to being easy to debug and easy to work with. We've spent a lot of our time worrying about compatibility. We wanted to make sure that all the time we've been using Upstart, which is since 2006, so it's been 4 years using this daemon that we've been surely writing, we've still maintained all of the layers beneath. In fact, for the first 2 years or so of using Upstart, we never Upstart itself wasn't responsible for any of the boots. It just we just handed back over to the sys5. Sorry, I'm slightly off the. Upstart itself actually didn't handle all the boots. It just handled back over to the sys5 init scripts. It was replacing the sys5 init daemon, and then we worked for quite a while on the CoreOS bring up. In Ubuntu, the CoreOS bring up was transitioned to Upstart mostly in Intrepid, I believe. And since then, there's been some more work on handling the services and bringing those up. But it's just as much a research project as it has been a engineering project. It's not a quick fix. It wasn't quick to develop, and it's still ongoing development. It's still figuring out how to make it work properly, and so on. So that's kind of the history of how we ended up at Upstart, and the history of why it works the way it does. And it clearly works. I mean, the Upstart is very, very clearly able to boot a Linux system. We boot Ubuntu every day. We've got God knows how many million users out there booting this every day. Current editions of Ubuntu use a large part of the first 3 layers are actually being booted through Upstart every day, and so on. So we are very clear that it worked. And obviously the next task for Upstart is now going to be addressing some of the problems we've had with it. There are problems with it. Addressing some of the the difficulties in syntax, make it easier to use. Bringing in some of the other first-class events that we wanted to be able to do to bring up the services layer and the desktop layer easier, and then work on from there. So that's kind of my history of Upstart. And I guess the next thing probably is to do some questions, because I've rattled on for about an hour, and I want to now kind of get an idea what people will ask. So I'm going to turn to my Andy IRC person.
Well, there was Pitty's original question. Why would the init daemon actually have to care about dbus? System C certainly didn't either. I guess you really did answer that.
Okay, so I'll go back to Pitty's question actually. Why does the init daemon care about dbus? Why? We have all these lists of things. Why am I singling out this one in particular? I'm singling out this one in particular partly because it was a big stumbling block when we were playing with LaunchD, and that it was actually a particular headache we had, and we started beating our head against the wall. And more point, a lot of the desktop layer is started with dbus. And a lot of, increasingly, some of the services layer was starting with dbus. And even back in Dapper, we knew that that was going to increase. We knew things like policy kits type services and and network manager and so on. We're going to go increasingly dbusy. And thus, if you're going to do an init daemon and you're going to say, well, we're not going to worry about desktop startup, and we're not really worrying about some of the system services. Whereas system services and server services could be different. If you're actually thinking about a server, what you really mean is servers rather than services, and they kind of sit alongside desk services and desktop. System services bringing up on a bridges between user space and kernel space and so on. Core operating system bringing them, and so on. So if you're already saying, well, we're not going to worry about desktop because that's relying heavily on dbus. If you're not relying on services to bring the system services, which are going increasingly dbus at the time, then you're really saying an init daemon brings up only the core OS, and and the UDEV daemon can do the firmware. So you're saying, right, okay, let's just have an init daemon that brings up the core OS. Well, and then you get back to the same kind of argument we had way back in sort of the earlier stage of Ubuntu, which is, well, if we were going to do this, we could just say that the right way to do everything is to move all services to dbus, to move all desktop stuff to dbus, to have firmware managed entirely by UDEV and so on, and have the core OS hard-coded. And that was very much an option, and we did think about it. But ultimately, we opted for a situation where we could actually bring up the whole system, with complete flexibility of configuration. We want to be able to do things like ship a version of Ubuntu, which is just missing a whole bunch of configuration and is cut down. Have the difference between two pods, and so just being the set of configuration. We don't want to have two different variations of the core OS bring up script. We don't want to have 4 variations of the core OS bring up script. We don't want, and so on. So yeah, why do we include dbus? Because dbus is important for the bottom 2 layers, and if you don't care about the bottom 2 layers, replacing this second layer wasn't worth doing anyway. We would have never written the replacement in daemon. We would have gone and done something else instead with the time. So that would be why dbus. If you're going to do it, you might as well do it properly, or overdo it. That's my motto in life.
So consistency, basically.
Consistency, and if it's worth spending the time doing something, it's worth overdoing it. It's worth replacing the world rather than just cleaning it. Okay. Andy, questions?
I think there's a question here. Can you comment on systemd versus Upstart? I.e. everything you explained, event engine, socket activation, dbus, etc.
Okay, so this is
why
right. So hi Lenny, nice to actually see you on board. Sorry I didn't see you at plumbing. Why continue with Upstart? It's a very good question, and actually I answered this not too long ago with why. If systemd already exists, why do we continue with Upstart? Well, if Upstart exists, why did you write systemd? I know the answer, but we're not particularly ready to go to that one here. It's one of these cases. I looked at initng, and we looked at launchd, we looked at existing init daemons at the time, and we couldn't get them to work with the set of things we wanted to do. So if we're going to do it, we may as well do it properly, right? We may as well go and do something else. If systemd had existed 4 years ago, we'd have probably used it. And this is the irony, that systemd probably would have coped with enough of the things we cared about, and that someone else was already worrying about this kind of thing, and someone else was already worrying about this kind of thing. It's certainly much better from initng, and it's certainly much better from launchd at the time. You can still deadlock systemd, but it's nowhere near as easy because much of the system, the other thing is, in the 4 years in interim, much more has moved to dbus, and many of the kind of things we used to have problems with have actually gone away anyway. HAL has gone away, and so on. So yeah, if I was to do this now, if someone was, if we were to be at UDS back in Florida, and we'd been deferring replacement in it, we'd never done it. Someone brought it and said, "There's this systemd thing, do you want to use that?" Yeah, I guess. Yeah, I mean, it looks all right. I mean, we can do some research on it. The problem is, now, we've been doing this for 4 years. We've built an entire operating system around a forward booting system. We've built, entire products that we go out and sell to our customers as Canonical to actually go and, which are based on Upstart working the way it does. We have derivatives like Chrome OS and like Palm OS and things like that, which rely on the way that Upstart works. They're actually even more Upstart native than Ubuntu is, and use features of Upstart Ubuntu doesn't even go near yet, and have actually added features to Upstart that Ubuntu. There are patches out there to do TCP on Unix and Upstart, which have never been folded into the canonical version of Upstart because of policy, and there are other things out there. So the simple answer is, can we go and switch to systemd now? It would be multiple years' work. We'd have to throw away all of our code to do bring up file systems. We'd have to throw away all of our code to do the MFS. We'd have to throw away entire products that we sell to vendors like Ubuntu Lite. We would have to rethink all configuration. We'd have to teach all of our users about differences in configuration. We'd have to teach all of our users about bring up. There comes a point at which throwing something away and going to something else is a hell of a lot of work, and it becomes a very, very difficult proposition. And it sometimes is the right thing to do, but ultimately, and this is personal opinion, as you and I have never quite agreed on what the difference is, I still think my idea is better. And all the time I'm doing something in a Linux distribution, I'm going to say my idea is better. I'm going to carry on with my project and get that to work, because yes, there's a quick fix solution, but actually the reality is the quick fix solution is going to take just as long to get working with a whole lot more pain as continuing with the current solution, which I think is better anyway, ultimately better. And that would be what I would say. And the other reason is to come back to, Canonical is obviously free to make a different decision. I think it's relatively public knowledge by now that I'm leaving Canonical. So Canonical could make a decision to ask us to use systemd. I still think my way is better, and I think they'll have a whole ton of problems switching to systemd, especially as their boot guys kind of left Canonical. But that would be my. I guess if that's my answer, I guess. If systemd existed 4 years ago, we would have used it. But I still think Upstart's better, and I know your reason for doing systemd instead of Upstart, and I think that's quite sad. It would have been much better if we could have just sorted that reason out, but that wasn't in our control. So yeah, that would be the answer. I think, it's too hard to switch now. Too much momentum. I'm just actually, I can see. So I see if I scroll and I move here. So I'm just going to quickly see if. Right. So. Okay, just to come back to just explain. It's not just no technical reason. It's as I said, I technically believe systemd is not as good as Upstart, but also to the point that. Let me just try and work out the easiest way to explain this. Yeah, as I said, systemd and Upstart's modus operandi is completely different. They behave differently. Yes, systemd has fsux stuff for free. Yes, it has mount stuff for free, but it's different to Ubuntu's mount stuff. It's different. Yes, you could rip out Ubuntu and replace it on Fedora. Yes, that's a project. Someone could go do that. You could rebase the entirety of Ubuntu on Fedora, but it wouldn't be Ubuntu anymore. It would be a different operating system with a massive set of release notes for that release, telling everybody that, well, actually your system's completely different. There would be a massive amount of work to upgrade everybody's stuff from one to the other. So yes, there's a technical reason there, which is my technical reason, but I think for Ubuntu as well, there is a massive, work. It's a massive amount of work to change systemd. I think it's not just like that. It doesn't just drop in. And upon that as well, I mean, our layers are this different. Systemd using init ramfs, we probably have to switch to Dracut because whole bunches of init ramfs assume we're doing, event-based bring up of a system, not config-based. Whole chunks of core OS would change, LDM, LDM, all things we've got working, crypt setup we've got working, would actually all be changed. Would have to go through all the same pain again. Anyway, so cool. And the obvious difference is why can OpenSUSE and Fedora switch, Upstart cannot, is Fedora and OpenSUSE never used Upstart. They replaced sys5init with Upstart, they never actually used Upstart, so they didn't have much to rip out. So you have really the same system, sys5init to something change, which can be slower than perhaps something to something.
So you're saying they're converting from one dependency-based system to another dependency-based system, therefore they're quite compatible.
They're converting from a serial-based system to a dependency-based system, whereas we've already converted a serial-based system to an event-based system, and they would replace an event-based system with a dependency-based system, and so on and so forth. Yeah. And Canonical is free to go do that work if it wants to. Okay, I'll just answer one. Lenny, I just want to make sure I want to give everybody else a chance to ask the questions. I don't want it just to be a Upstart versus systemd unless that's what everyone else wants it to ask. Why we've had agreement with various times. To be honest with you, I remember us having. I'm going to just be snide for a second. I remember us having an agreement that you weren't going to write systemd and that you were going to contribute network-based activation to Upstart. So, and why have I backed off? Because there isn't really an advantage for us to use the systemd API in config format because it's already different enough that it wouldn't work the same. Compatibility is just merely a way of saying what was it you said earlier? Compatibility is just a different word for similarity, and it would be surprisingly similar. It's only insimilar. So yeah. So pity. I'm just going to quote. Is that question? System dependency. Pity. Joy. I prefer a forward-based system because it's being proven to work and can implement a backwards-based system. I prefer the forward-based system because it's been proven not to have the same deadlocks a backwards-based system can have. It's consistent, it's elegant, it's very, very simple. Upstart is really not that much code, and so on. So, sure. Okay, so I'd like to see if there's some other questions that aren't this related. If not, we can come back to this topic. I don't care about these common interfaces because I don't care about app developers. I think that the app developers will use whichever operating system has more users, and I think we win. Ha ha ha. I just don't see that as a massive problem. I mean, there is an app developer standard out there. It's called the LSB. We both implement it. We already both implement a common interface. That common that common interface has already works. It's fine. App developers have been using it for years. We can continue to support that common interface. So you are interested in competition, not cooperation at all. I am interested. I don't know whether Canonical is or Ubuntu is, but I would also say that the person is saying that's sad is the person who, instead of collaborated and cooperated with maintaining an init daemon, went and wrote his own in secret for 6 months. So again, I think you need to kind of consider that you went and didn't collaborate. Okay, so any other questions? Anyone got anything particular they want to ask me about Upstart that's not related to systemd?
One of the things that came up on RC in the background was about the starting being something that happens before starting starts, as it were, and brought up an interesting question, which is the more interesting part, which was that if Apache needs MySQL, then the place you write that Apache needs MySQL is in the MySQL definition, and you showed us a little trick earlier that turns that round.
Okay, that's a really good thing actually. Let me go do that because that's something that everyone who uses Upstart should learn. Okay, right. So we just had a question here. So okay, we have. I'm not going to use Apache and MySQL because they're always just examples. So let's use two jobs, foo and bar. Okay, foo and bar. Right now, we normally would say that. Can everyone see that? Okay, I think so. It's fine. Right. Foo. If foo is started, we first need to start bar. That's a way of saying it in Upstart world. We have an event system. So in foo, I'm going to try and write this as large as I can for everybody, as thick as I can. We would say start on stuff, right? In bar, we would say something like start on starting foo. Right. Can everybody read that? Okay, I hope so. Andy, please check my feed.
I'll let you know when it's
all right.
a little small, but I think it's top line's legible.
Okay, right, so foo is started on something, start on starting foo in bar. So when we start foo, or foo is started, it will issue the starting foo event, which will happen inside bar, will be passed to bar, will cause bar to start, it will still hold on to that event, bar will finish starting, let go of the starting foo event, goes back to foo, allows foo to continue. Simple dependency. Now, what most people don't realise, and I realise that I've never really documented this except in the man page, is that actually start on starting foo is a shortcut. It's actually just a kind of a bit of syntactic sugar. What you're really saying, and I'm just going to use the starting part, is starting foo is just that whatever the first, you're matching the value of whatever the first environment variable of the starting event happens to be. So this is the event name. Foo is just an environment variable. In fact, actually what you're really saying is start on starting job equals foo. The job just happens to be the first environment variable in the starting event, and that's guaranteed by the API. So when you say start on starting foo, what you're really saying is shortcutting start on starting job equals foo. Okay, so starting is the name of your event, job equals foo is one or more arguments to match when you're starting foo. You can put as many of those as you like. You can say job equals foo, blah, blah, blah. Anyway. Okay. The other thing that most people don't seem to therefore pick up is job equals foo is optional. You don't actually need to specify a job name there. It's actually completely optional. So just start on starting is a valid Upstart term, and that will cause your service or task to be started whenever any service is started, or job is started, or task is started. Okay, starting job equals foo. Now, okay, we can also match any other event, any other part of the environment here. So if we could put something into foo's environment, we could actually start match on that. So in foo, as well as start on whatever, we could say environment variable called needs bar equals 1. So the foo job has $needs underscore bar equals 1 in its environment. And we can say export needs bar. Now in Upstart that means something specific. That means not only put the value of needs bar into the environment of foo, but put it into the environment of every event related to foo. So now we can say starting, instead of job equals foo, we can actually just say starting needs bar equals 1. So we can now replace out the bar, instead of say starting foo, this is just the same as what I've written there, is 1. So you can do dependencies without naming the list of jobs. So you can have foo says just needs bar is 1, export needs bar. Bar can say start on whenever anything needs it. Start on needs bar equals 1. Yes, Pity, you can do state-based dependencies this way. The other thing you can do with this, so you could actually say, right, needs bar is 1, whatever. The other thing you can do with this, which is also kind of fun, is, well, okay, so we have a whole bunch of jobs the other way round, which are like GDM, KDM, LVM, XDM, WDM, they're all display managers. So in those GDM, when we have a whole bunch of things like Plymouth, which say start on starting GDM, or starting KDM, or starting LVM, or stop on stopped KDM, or stop GDM, or stop KDM. We have a whole bunch of things like that. Instead, we could put in the GDM conf and the KDM conf and the LVM conf, display manager is 1, export display manager. And then all you need to put in Plymouth is start on starting display manager is 1. So start on a job which has display manager 1 in its environment. And yeah, you can therefore you don't have to use job names. You can tag jobs, you can effectively use environment as commands and so on, which is a very sort of easy, powerful thing to be able to do. And this is where a lot of the stuff we've been talking about as extensions to Upstart comes from, is just merely utilizing this. It's just providing some a better syntax. The whole start on stop on syntax is there because it's the easiest way to express the events. Unfortunately, it's the hardest way to express when a service should be running. But really, we're just talking about tagging jobs and so on. So if you understand that the starting or starting foo, the foo is just an optional argument and it's just a placeholder for job equals foo, you can realise you can replace it with anything else or nothing, and you can start to do much more powerful things in Upstart than you weren't aware of. The other thing you can do as well, remember, is not equals. So this is a perfectly valid starting. So is job not equals Apache or not equals foo. So you can start on when everything that's not foo started. This comes in useful if you look in the stopping event or the stopped event. You can actually have start on stopping result not equals OK, i.e. have a task started whenever a service fails. There are a whole bunch of things you can do here with the matching that are much, much more expressive than simply dependency names and so on. And that's where, coming right the way back to the original design of Upstart, that's where all the power comes from, the fact that job names are merely one piece of information. There are many, many other information you can use. Okay.
Another question?
Yep, please.
Pity asked, one thing that's desperately missing is state-based conditions, similar to MVBall's question about is that planned soon?
Yes. Simple question. It's something continued. I don't think here, Andy, what question Andy's reading actually. Are we planning to do state-based stuff, or am I planning to do state-based stuff? Yes. They seem to lose lots of time in building. Let's have a look.
Somebody asked, I can't find it now, but I saw it. Is that what sort of debugging support do you have?
Okay, what sort of debugging support do I have? Well, the first thing is, as I come back to just here, and that's a great time to ask that question, is because you can started, stopping, stopped events, you can therefore use those to do debugging. For example, if you want to be able to manually step through the boot, just stick on start on starting, match all jobs, task, i.e. block everything until this thing finishes, OpenVT, TTY7 bash, or a script with whole bunches of stuff printing out first, like the environment of that job, and you've now got a shell on TTY7 for every, while you boot, to let you introspect what's happening with that job. You doesn't have to start a shell. You could echo stuff. You could put time stuff in a log. You could put statements. You could therefore check the PS, and if it's meeting a certain way, go in and hook in and back in. You can also do stopping. So you can hook every operation of Upstart, because every operation of Upstart is just an event. So you can hook into all of those. And then obviously you've got things like init, verbose. If you put minus verbose on the command line, init will just tell you what it's doing all the time, and so on. So yeah, you could because you can use the event system to hook into everything. It's relatively nice to debug. Okay. Okay, I'm going to ask a question. Will development continue after I leave Canonical? Yes. The details of that are obviously, so on, but obviously to be exactly decided. Who's going to be upstream, or whether I'm going to be contributing to Canonical upstream, whether Canonical's going to be contributing to a Google upstream, and so on. We actually don't know. We haven't thought it out yet. But there will be no thing. And within Canonical and Ubuntu, Ubuntu and Canonical have hired somebody to obviously replace me in the work I do, and he's hiding in the corner of this room, cowering and taking notes. But he'll do brilliantly in Ubuntu. So I'm not expecting any problem or any thing. I actually don't know what the cup sander problem is, so I can't remember the cup sander problem.
I think it looks like the resolution was it's a sort of a needs cups kind of a thing.
Yeah,
so very
exactly.
similar.
Yeah, and I'm pretty sure I remember suggesting that at the time, but I can't remember whether I did or I didn't. It may have occurred to me at the time, and I've been hiding from IRC because it's full of people that make me want to try things.
It does feel like there ought to be a shortcut way of saying that env equals
there will be. That's one of the things that's why I talked about UDS. There will be a lot of shortcuts for this stuff. And the more shortcuts there are, the more obvious it will be that this one shortcut wasn't really was only a shortcut. Yeah. Actually, I'll just ask you, pity. Sound doesn't work right. I'll have to talk to you about that one offline. I don't know what the details are. There are plans to integrate GNOME with systemd. That will make our life quite hard, won't it? I guess it would make it quite hard if we actually use GNOME instead of Unity. I'm going to be completely sort of silly there, but yeah, the simple fact is, as far as I understand Ubuntu's plans in this regard, is that Ubuntu doesn't plan to use GNOME Shell or anything anyway, in which case the actual depth of what we do and what we share in common with GNOME and Fedora Linux would be various anyway. And we've found it not very hard to have our own init daemon for this long anyway, so it's not very hard. But yes, I don't think that's a problem. And besides which, I would point out to GNOME that potentially they've got one, if they rely on one distribution, if they rely on an init daemon that only exists in one distribution, they've probably got their own problems. And so on. Obviously OpenSUSE is going to be it's just been bought by Microsoft. Trying to show if I can't read our sequence correct. So Unity isn't a different front end. Apparently Spatula's got hold of Lenny's IRC. Still no Wikipedia, I would point out that the 90% is the invisible 9% that doesn't use the init daemon anyway. It doesn't use the session manager, so the Bing bit uses the session manager as the shell. Mark, what's the status on getting Upstart in Debian? I can answer that question. I think it's basically the same status as getting Upstart system in Debian. I think we've got a particularly strong group of people who are working within Debian. They're working with the policy team in Debian to make sure that Debian is open to replacing the sys5 init daemon with other alternatives. And we've been quite careful all the way to make sure it's just other alternatives and not Upstart specifically. We've made sure we're covering things like upgrades and stuff like, which is the hard bit in Debian. Remember, Debian, we've got to support upgrades. You can't just wipe your machine. We've been making sure there's a lot of effort to understand the policy for where if a package manager wants to ship different versions of the init daemon or different init config files, it also ships the sys5 init config file because Debian's not going to switch off system 5 init overnight. And we've been talking with the sys5 init maintainer for many years, and we've come to agreement. I would say it's probably the same. If I was a betting man, I would say that Debian is going to support multiple init daemons, just as Debian supports multiple just about everything else. I think that's going to be the way that Debian's going to go. I don't see Debian settling on one init daemon. I can't see Debian ever settling on one desktop environment. I can't see Debian ever settling on one libc. I can't see Debian ever settling on one incursive implementation. It's just one of those things. I think they will always support multiple. So yeah, and packages will just deal with it. And likewise, I go back to we have a common standard, the LSB init standard. It's still there. Any other questions?
There's a question: status of proc connector.
Are there other options for replacing ptrace for expect-port? There are lots and lots of options. There's lots of very interesting ways of tracking processes within an init daemon. None of them are very interesting. If anybody really wants to get into a nitty-gritty conversation about how you can do process tracking, how you can do service containment, and so on, then yeah, it's a very interesting conversation to have between two init daemon geeks. But to be honest, it's all invisible to the user. It doesn't matter. C groups is one way, I'm sure everyone knows about, which systemd does. C groups has its own disadvantages. I'm actually working at the same company as the C groups maintainer, which should be obvious to many people. Proc connector is a very good way. Proc connector has its own disadvantages, the fact that it's always slightly behind the times, and so on. I mean, it's just one of those things that's not very interesting. But yes, there's lots of options, and some of those options aren't in the kernel yet, and aren't actually public.
So what's the status of getting Upstart in your init ramfs?
The person what's the status of getting Upstart in your ramfs? The person who's been doing most of the work on that is our file system sort of support maintainer Serbi, and she will answer that question far better than I can. We discussed it heavily at UDS, and the process for doing so is relatively simple for us because our init ramfs is already event-based, and the tapes just come off the bag I was hiding the light with. So if Serbi is the person to ask, and is the person tracking that. Yeah, I would say that's the right thing. Cool. We've just come up to an hour and a half, so I'd like to just go quickly and ask questions or ask things people would like explained, or in this room as well. So, There's a lag.
There is a lag.
Yeah, now you can see the bag. There is no fire. It's annoying.
There doesn't seem to be any additional questions.
Oh, there we go. Okay, great. I think we're probably out of questions and out of time. So, yeah, if anyone wants to grab me, just feel free, and I'm usually on email, so it's probably useful. Hopefully, be able to answer some questions or something. Probably not. All right, great.